I'd like to start by thanking the organizers for this conference, and I'm very honored to really speak in front of this gathering. I'd like to mention the position documents presented by ASHRAE on refrigerants and their responsible use. First of all, I'm going to define what we mean by position documents. I'm going to go over refrigerants overview, alternative technologies, and issues for consideration. Of course, when we present technologies, we do not have a decisive conclusion, so always present issues that needs to be considered. Now, position documents are really board-approved documents, and what we mean by that is ASHRAE future and goals will be to go in that direction. So it really represents the opinion of the board, of all the technical committees when we put the position documents. Previous speakers took us to TS diagrams. I'm going to take you to pH diagram. A little bit goes well with this gathering here. We are in university kind of setting, so we might as well go to the first slide that we are very familiar with, the vapor compression cycles. What we're doing here, we're taking heat from a low temperature reservoir and throwing it outside into hot temperature reservoir. Nature has told us that heat goes from hot to cold. What we're doing here, we're taking heat from cold to hot. Of course, we have to keep some trace on the environment. And this trace is given by the work of the compressor. We need the compressor to do this job. But this job cannot be done alone without the compressors. Now, what takes this heat is the refrigerant inside the cycle. So a lot of things could be said here about this cycle. Of course, the heat exchangers, the expansion, the compressors, what type of, how the mechanism takes. If we have a lazy refrigerant, we're going to leave more trace on the environment. If we have a good refrigerant, we have less trace and so on. Refrigerants basically are the working fluids in refrigeration, air conditioning, and heat pumping systems. They absorb heat from one low temperature reservoir and throwing it outside. And basically, we have known these definitions way before. Now, when we speak about classifications of refrigerants, we have really 4 groups. And, of course, we start earlier with the CFCs, and they are now history. And we're still talking about the ODS and GWP refrigerants, which are the HCFCs. And we're all familiar with the phase out. We have mentioned a lot about this morning. So basically, this is going to be history probably in the next 5 to 10 years. Now, what are the replacements? We are proposing now an HFCs. And some of them, now we're facing the issue of high global warming and low GWPs. So now we're at the era we're discussing the low GWP refrigerants, which are the HFOs, and probably 32, I don't know where 32 fits in the high, in the moderate, or in the low GWP. And of course, the natural refrigerants, CO2, ammonia, and hydrocarbons. So this is really the whole pictures. And no one has come with really big invention to come up with the different vapor compression cycles where we do not need those refrigerants. So we have to deal with those, and we have to do a better job in the way that we treat them, the way we work with them, and so on. So again, we're talking about the different generations here. This is another one. Then when people phase out CFCs, they were smart enough in some applications to go all the way to natural refrigerants. So they saved probably the intermediate steps into the HCFCs. But some went also to HFCs as some of the chillers, some of the automobile refrigeration. But most of the systems went to HFCs, and now they are in the era of transforming those again. So I guess we have to be very careful when we address now natural refrigerants and HCFCs and low GWCFCs, what kind of direction we want to put in the markets here. I mean, we are paying a lot of money to shift from one refrigerant to another shift and so on. Of course, as I mentioned earlier, the compressors have a big portion to play here. We're talking about different range. This slide tells us really what kind of compressors that works better: reciprocating, rotary, scroll, and centrifugal for low different capacities. This is also a big issue here. Now, refrigerants also depends on the refrigeration that we're looking for. Some of the application requires flow, high flow. Some requires high lift. So it depends on where the refrigerations are. Some of them needs a lot of CFM per ton. So we talk about this certain refrigerants. For high lifts, we speak about different refrigerants and so on. So where we are now, what's the situation right now? HFCs are greenhouse gases, and they have GWP effects. Some applications, the indirect effect is a lot more than direct effect. Again, it's not really fair to speak about only the direct effect of the refrigerant. we have to also look behind the indirect effect, which is the efficiency, which is the power consumption, which is the CO2 produced at the power consumption, energy, and so on. We are speaking about TIWI, and I'm very happy to hear those terms now, and LCCP. We're really looking at the whole system and the consumption of CO2 all the way from the production to the end of the system. And we have Montreal Protocol, no specific mandates for reducing the HFCs, as we have mentioned earlier by Jim and by Didier. However, many countries, they weren't even proposing phase down of the HFCs in Montreal Protocol. Nothing has happened yet, but those coming up, I guess these kind of gestures and proposals are being discussed. These developments led to renewed and increased interest in natural refrigerants and the development of a new low GWP option. So this is really right now where we are right now. Also facts that GWP phase at different speeds around the globe. We have some issues in high ambient temperature, refrigerant selection and responsible operating systems, still not based on holistic analysis of multiple criteria, energy efficiency systems, performance, potential impact on community safety, risk. We have a lot of cost, of course, and minimize the direct and indirect. We have a lot of issues to discuss here when we speak about holistic approach. Not fair really to speak about only one aspects when we speak about refrigerants. Some HFOs are available in limited quantities, not yet fully tested, and some HFOs have low GWP, HFCs, they have mild flammability, high cost, and so on. So no ideal refrigerant yet, still natural refrigerants has been studied and has been proposed, but probably also some blends needs to be looked at again. Challenges in high ambient temperature, TEEP report 2012 has mentioned some issues with high ambient temperature. For example, the COP drops from 20 to 25 when we speak about high ambient temperature. Constraints in high discharge temperature and pressure lead to the choice of medium pressure refrigerants such as HFC 134, lack of low GWP refrigerants with large refrigeration capacity in order to replace 404 and HCFC in small units. So again, big issues here in high ambient temperatures, big studies needs to be done, and I think there is projects already by United Nations, by UNEP, are underway really to look into this high ambient temperature work. Now, alternative technologies, we do not have, in my view, we do not have one single refrigerant, of course. It's really size dependent and application dependence. Also, the selection of the correct refrigerants require capital cost, operating cost, energy, equipment size, location, and temperature, pressure, facility, and so on. So this really, there is no unique alternative refrigerants for us. CO2, we have seen the previous speakers talking about CO2. It has good application in low temperature applications. When it comes to high temperature, of course, it has its own challenges. As mentioned earlier, hydrocarbons, also it has the flammability issue. We have to be very careful about this. It has very good thermophysical properties, but this issue of flammability has to be studied. It has a very large range of boiling points, so the application really wide from cryogenic to air conditioning systems. So this is very good refrigerants to be looked at, mostly used in European countries and Asian, and used with commercial refrigeration system, beverage ice machines, and so on, from 0.3 to 40 ton. So this refrigerant is a good refrigerant, except this flammability issue. Now, ammonia, a barrier in the ammonia, we all know that ammonia has been, safety issues for the ammonia. We need to do more research in this. It's a very good also refrigerants to be used for large capacities. On the way really we handle ammonia, control emissions, and we need the new standards, new guidelines to look into the safety issues of the ammonia. However, ammonia has, as you all know, this smell that gives us really good alert. It has very low density, so the ammonia rises up when it is released in the atmosphere. So it has very good characteristics that we really have to build on to present it as a future refrigerant for high machines. So questions remains open. Issues with natural refrigerants include flammability, toxicity, high pressure, in some cases lower operating efficiencies, concern about the GWP of some HFCs, calling to reduce it, research to extend lower GWP refrigerants into new applications, The reduction has been proposed as phase down of the HFCs. At the present time, some HFOs are available in limited quantities, but they are not fully tested. Some flammability issues are in there. Research is also called to be investigated blends across refrigerants and their use. End-of-life disposal, something that we really have to look for to make sure that we are really getting rid of those refrigerants in a proper way. Research recommendations, so we really have to balance, ASHRAE really look at balancing the safety, energy efficiency, cost, environmental impact. I think this is what Raj has mentioned. We have such a study. I think ASHRAE tomorrow will be looking forward to the presentations to really look at the whole, holistically at the whole approaches in order to determining what's the best refrigerants. Advancing the design and development of refrigeration and conditioning equipment that facilitate and reduce the refrigerant emissions, of course. Developing methodologies and practices to minimize or prevent refrigerant loss during installation. This is very important also. If there is no loss in the machine, we cannot speak about GWP because those machines are contained, those refrigerants are contained within the machine itself. Developing new refrigerants that minimize environmental impact and safety concern. And with that, I would conclude my presentation. Thank you.
Thank you very much. Ci sono domande, commenti? I have a question. What is the real attitude of the people in the States, of the laymen, not the official position of ASHRAE, in the States about the use of hydrocarbons? We have so many lawyers over there that they are ready to jump over the question.
I'm going to divert this question to ASHRAE. I guess I'm not really, living in the state, and I'd like to correct something that's mentioned about ASHRAE is the American, American site of air conditioning refrigeration has been already brand named. So ASHRAE is ASHRAE. It's not really the American society. It's a global society. So I do not live there to really understand this culture. But I could tell you that flammability is a big issue, not only in the States, but all over the world. And I guess it's something that for hydrocarbon, for example, we have to really be careful about the application. But it has very good potential size-wise and good drop-in for R22. So I guess it's a very good refrigerant to be looked at.
Thank you. Qualche domanda? Prego. Arriva adesso.
Yes, it's still again about the hydrocarbons that you said is excellent refrigerants. And they are widely used all around the world, practically, and I think also in the US, starting in outdoor refrigerators, and also in commercial refrigerators that is growing. And of course, flammability is a concern, but all these type of applications in the world show that in reality it's possible to take measures to have safe applications. The limit now for the refrigerants to use generate, you can place the cabinet where you want, also the commercial, the limit is 150 grams. In order to extend this use of refrigerant in larger cabinets, should be very interesting to increase the refrigerant charge and use the refrigerant, for example, 400 grams in cabinet, like now is 150 grams. What do you think that this is some way that should be followed? Because we think that in Europe, at least, that time is now is the moment to extend this, because 150 grams already demonstrate to be safety enough all around the world.
Again, now I'm speaking personally, not on behalf of ASHRAE. I always think this is a political issue, really, when we go to natural refrigerants. I mean, this all issues about safety should be really revisited again. I guess we are in an era that advancement in control systems are very well, could be done. Ammonia could very well be, detected if there's any leaks, hydrocarbons, similar things. I think, it's political call has to be made, in my view, and shift the whole thing into natural refrigerants and not to really dwell on this. Of course, we do have challenges, but if we have political decisions, I think everything will be drifted in that direction. Yes, we could do it. Refrigerant charges has been studied very well, not only in hydrocarbon, but also in ammonia. And we have seen that there is a big advancement in there. we could do a lot better job if the decision is there. And I guess, you know, we should be in that direction, in my view, eventually, yes.
Thank you. Altre interventi, prego. Lì.
Just a question about the low temperature applications. Okay, I'm Mr. Quattrocchi, working for Angelo Antoni Group. So we build environmental chamber down to minus 70, minus 80 degrees C. We see R23, like we use for lower evaporation. And there is an alternative to hydrocarbon and natural gas, other options, HFO.
In low temperature applications?
Yeah, that is not ethane, ethylene.
I guess you're asking the wrong question to me, because the question to the wrong person. I live in Kuwait, temperature 50 degrees C, so I'm more familiar with that. But anyways, I'll be glad to mention. No. I think, in my view, you know, natural CO2 is the application to be used in low temperature applications. I'm not familiar with any other refrigerants that would do the job. I mean, you know, unless somebody from the speaker, I'm not very familiar with the low temperature, except CO2.
Nessun altro commento, nessuna altra domanda? Thank you very much.
Thank you.
Thank you.
Thanks for the introduction. Again, I'm very happy to speak here. I'd like to comment a few things. I think we've mentioned yesterday some points. I'd like to say, really, after all these discussions, that global environmental concerns are becoming increasingly challenging, affecting the process of development and accumulating additional burdens on economies, particularly in the developing worlds. The environmental issues, global warming and ozone depletion, are really realities. There was big debates about those 10 years, 20 years back, but now they are realities, and we are facing really some big concerns because of, you know, of how much CO2 that we are producing and injecting in the atmosphere. The environmental issues are so severe, so everyone has to start implementing and not only thinking about solutions. I think we have enough thought. It's time now to put actions on the floor. We know the solution. No one could say that, you know, that there's no obstacles. Of course they do, and there is a lot of technology that needs to be accumulated with that, but we do have the solutions. It's time to really implement. We need to send strong messages to implementing agencies and to politicians, I guess, to really, you know, put the right solutions on the table. And really, this is not really the concerns only of the companies, but I guess professional societies. And here's a big call. I extend my hands really to all the professional societies to put our hands together, all of us. We need all of us really to work together to put really concise solutions on the table for the industry to follow. We are in an era that really industry are kind of, you know, not clear on which direction they need to move as far as refrigerants is concerned. But we know the solution, and I think all the professional societies have to really work hard to come up with standards, and we do have standards in place to put them on the table and to direct, I think, the whole business in the right directions. Speaking about some actions, some implementation, some practical solutions, I'd like to say a few collaborative efforts that were conducted, you know, in the area of refrigeration and energy efficiency. The first one, I'm going to speak about UNEP and UNIDO. They really have put an effort to conduct research in the area for high ambient temperature countries to look for solutions for what's the next refrigerants to be used. The project calls on bringing manufacturers, compressors, technology providers, and they all will really work together to come up with a prototype, and those prototypes will be tested under the same conditions, so we could probably compare apple to apple, and the results will be, you know, trustful, because they're going to be independent labs done similarly, same conditions, so at different units, different capacity, and that hopefully will be completed in 1 year. And by then, I guess we could really see how we move in which directions for high ambient temperature countries. Also, another collaborative efforts, ASHRAE and UNEP are collaborating on projects to design guideline for sustainable refrigeration facilities and systems. I guess the guide will serve as an important new international reference with valuable recommendations, methods, and examples. Subjects include refrigeration system and facility design, cooling laws, equipment, choices, and performance modeling. This design would really serve the industrial refrigeration tremendously. Also, we do have refrigeration commissioning design guide in place. We're working on that, and that's going to be done this year, where we really send the right messages on how to really commission and refrigeration systems, step-by-step, applied approach, because we believe that commissioning, big issues are in there, of course, as far as leaks is concerned, whether we're delivering the right design or not. Also, we are working with IAR, EPA, Ammonia Institute of Refrigeration in conferences that would really address environmental issues. And I guess those kind of conferences, they are kind of decision-making things, because at the end of those, we come up with recommendations, and then we put those forward to the governments. Also in Qatar, we have many HRI, ASHRAE, Qatar Foundation, RIVA, SIPSI. They all are working also together to come up with a conference, international conference on energy and refrigeration in the area of the Middle East for high ambient temperature countries. As I mentioned, there's a lot that needs to be done. We could do so much. We need to put our hands together. This is a call for all of us to make a difference in the world that we live in. Thank you.